Alright, you guys, if you could please turn to 1.2, functions and graphs. Alright, I'm going to write the definition of a function. A function from set D to set R is a rule that assigns a unique element in R to each element in function D. Okay, so if these blue dots represent elements in the domain, each of them correspond with something in the range. You can even have two elements in the domain correspond to the same element in the range. However, you cannot have the same element in the domain correspond with two different elements in the range. So, this is a function. This, not a function. Alright? Okay, write a formula that expresses the area of a circle as a function of its radius. Now, hopefully you guys remember that the area of a circle is pi r squared. Okay, so this would be the function we would be using. So this is our formula. That's the first part. Then it says, use the formula to find the area of a circle with radius 2. So I'm going to have a equals pi 2 squared. 2 squared is 4, so I've got 4 pi. And it's inches, so it's going to be inches squared for the area. Well, I gave you a lot of space for a short problem. Alright, you guys go ahead and try this, and when you think you have it, hit play. Alright, these are the answers you guys should have gotten. A cube with side length s, each face is going to have an area of s squared. So this is x squared, this is x squared, this is s squared, s squared, s squared. There are 6 faces, so the area is going to be 6s squared. And they tell us that s is 5, so you plug it in, you get 150 feet squared. Alright, identify the domain and range, and then sketch a graph of the function. Okay. It might actually be easier to sketch the graph first. Hopefully you guys remember the graph of 1 over x. Yeah. The graph of 1 over x looks something like this. As you can see, it gets closer and closer to 0, closer and closer to 0, but never quite gets there. Okay? So the domain is the x values. As you can see, the graph, if we were to extend it, actually goes all the way to negative infinity. So this is all covered. But when it gets to here, it doesn't ever get to 0. So it's from negative infinity all the way up to 0, and then it stops. Whoops. And then after 0, it continues again, all the way to positive infinity. If this were to continue, it would go all the way to positive infinity. Okay? I guess we can keep it in red. Now the range is the y values. Okay, so this, once again, from negative infinity all the way to 0, and then from 0 all the way to positive infinity. Remember, the parentheses means it does not include that number. If I were to use a bracket, that means it does include that number. So here's the answer to part A. Alright, part B. I'll go ahead and graph this. Alright, this is what the graph of square root of x looks like. The domain, once again, is the x values. There's nothing over here up until you get to 0. That's where the graph starts, and it includes 0, so I'm going to use a bracket instead of a parentheses. Okay, so from 0, and then it just goes on forever. Now the range looks similar. The range is the y values. From negative infinity all the way to 0, there's nothing, and then at 0, it starts. Now this does not level out. If you look at the graph, it actually just continues going up and up and up and up and up forever. So this also goes from 0 to infinity. Okay. Alright. You guys go ahead and try this one. Alright, I'm actually going to do this one with you guys because it's a little bit different than the one over here. F of x equals x squared minus 5. For part A, we're told that f of x also equals 4. So if this is f of x, and if this equals f of x, and this also equals f of x, we can set them equal to each other. And then just solve for x. So I'm going to add 5 to both sides. This goes away. X squared equals 9. I'm going to take the square root. X equals positive and negative 3. Same thing for part B. X squared minus 5 equals negative 6. I'm going to add 5. Add 5. X squared equals negative 1. The square root of negative 1, hopefully you guys remember, is I. So this is going to be positive negative I. Alright. Once again, I left a lot of space for you guys. Probably too much space. Okay. Use a graphing calculator to identify the domain and range, and then draw a graph of the function. Okay. Alright, I pulled out my calculator here. Let's go ahead and graph this. We've got the square root of 4 minus x squared. Let's graph that. I'm going to change the window. Just so we can zoom in a little bit. There we go. This actually goes all the way down to here. It's just kind of hard to see. So, you can kind of tell what the domain and range is just from the graph. The domain, x goes from negative 2 to 2, and it includes 2. The range goes from 0 to 2. Okay? Let's go ahead and write that down. Actually, let's graph this first. So the graph looks something like this. So the domain, negative 2 to 2. The range, 0 to 2. Alright, let's try part B. For part B, we have x to the 2 over 2/3 power. There we go. Okay, so once again, you can kind of tell what the domain and range is. It looks like the domain is all real numbers. The range, it goes from 0 to infinity. Okay, let's go ahead and write that down. Imagine that's a straight line. Actually, I meant to do that in red anyway. So the domain, negative infinity to positive infinity. The range, 0 to infinity. And once again, way too much space. I overdid it on the space this time, I think. Alright, you guys go ahead and try this one. And then hit play when you think you have it. Alright, you guys, this is the answer you guys should have gotten. The domain goes from negative infinity to positive infinity. The range, negative infinity all the way up to 1. Alright, even and odd functions. Alright, a function y equals f of x is an even function of x if f of negative x equals f of x. It's an odd function of x if f of negative x equals negative f of x for every x in the function's domain. Alright, so, for example, for each of these, we're going to test algebraically whether or not they're even or odd. So let's test if this one's even. You guys already kind of know this is even because if you remember the graph, it looks like a U, which is symmetric about the y-axis. But let's imagine that we didn't know that. Let's plug in negative x. Negative x squared is going to be just x squared, which is the original function. So f of negative x equals f of x. It's even. Let's try this one. We've got negative x squared plus 1. Once again, negative x squared is just x squared. And what do you know? We get the original function. So this one is also even. Let's try this one. If I plug in negative x, this does not equal x, so it's not even. Now let's try this. Negative x, if I were to multiply a negative sign by everything in the function, which in this case is just x, these two are equal to each other. So f of negative x does in fact equal negative f of x. So it's odd. Let's try this one. If I plug in a negative x, I'm going to get negative x plus 1. If I multiply a negative by the whole thing, I've got to distribute this negative. So I've got negative x plus 1 equals negative x minus 1. These are not equal, so it's not odd. Let's try for even. If I plug in negative x, this is not the same as this. So this one is neither. Alright, you guys try these two, and then when you think you have it, hit play. Alright, these are the answers you guys should have gotten. Wow, that's a sad box. Oh well. Okay. Graph the piecewise function. Okay. If you guys remember, piecewise functions are basically pieces of different graphs stuck together. So for example, the graph of negative x looks like this. Okay? But we're only doing this all the way up to 0. So that's the first part of our graph, and it actually doesn't equal 0. There's an opening there, all the way up to 0. Now, the graph of x squared looks like this. But in this case, we're just going from 0 to 1. So there's just this part here. Okay? And it goes all the way from 0 to 1. And then it equals 1 when x is greater than 1. Now, anytime you have just a y, you're going to get a horizontal line. I don't know. Let's use purple. So this is the graph of y equals 1. But once again, we just want this graph from 1 onward. Alright, so this is our piecewise function. Okay. You guys go ahead and try this one. Alright, this is the graph you should have gotten. It's important to note that the pieces of the graph do not connect, unlike in here. Okay?
I like that.
Alright, so here now we're going to be working backwards. It says write a formula for the function y equals f of x whose graph consists of the two line segments in the figure. Actually, I think there's 3. So this one